Hey friends, today we'll talk about the Floyd cycle detection algorithm. As the name suggests, this algorithm has two objectives. One, to determine whether a cycle exists in a linked list or not, and two, to return the node where the cycle begins. For example, in this linked list, there exists this cycle, and the cycle begins at node 6. Now, let's look at the brute force approach to detect a cycle in the linked list. To do so, we can maintain a hash set and we iterate over the linked list. At every node, we first check if that particular node exists in the hash set. If it does not exist, then we add it to the set and we move to the next node. If the current node exists in the hash set, that means we have already visited that node before and there exists a cycle in the linked list. And that's the node where the cycle begins. So now let's talk about the time and space complexity of the brute force algorithm. In this brute force approach, we are visiting every node at most once. So the time complexity would be big O of n, where n is the number of nodes in the linked list. Here we are maintaining a hash set and we are adding all the nodes in the hash set. So that would be space complexity of big O of n. The brute force approach has a space complexity of big O of n. Floyd suggested an approach that eliminates the need to have this extra space. Floyd's algorithm requires us to maintain two pointers which will iterate over the linked list. A slow pointer which will move one step at a time and a fast pointer which will move two steps at a point. Since these two pointers start at the same location and their speeds are different, while iterating over the linked list, if they meet at any node, then we can say for sure that there exists a cycle in the linked list. Now, let's look at this example. As I mentioned before, we'll maintain two pointers, fast pointer and a slow pointer. Slow pointer will move one step at a time and fast pointer will move two steps at a time. So let's start the algorithm. Fast pointer will move here, slow pointer will move here. Fast pointer will move here, slow pointer will move here.
Fast pointer will move here, slow pointer will move here. Fast pointer will move here, slow pointer will move here. Fast pointer will move here, slow pointer will move here. Fast pointer will move here, slow pointer will move here. Fast pointer will move here, slow pointer will move here. Fast pointer will move here, slow pointer will move here.
So as we can see now, the fast pointer and slow pointer meet at this node. So we can say for sure that this particular linked list has a cycle. Now we need to determine where the cycle begins. For that, we can move the slow pointer to the head and we'll keep the fast pointer to the node 9 where earlier slow pointer and fast pointer met. From here, we can move both the pointers one step at a time and the node where both these pointers meet, that node is the one where the cycle begins. So slow pointer will move one step, fast pointer will move one step. Slow pointer will move another step, fast pointer will move another step. Slow pointer will move another step, fast pointer will move another step. Slow pointer will move another step, fast pointer will move another step. Slow pointer will move another step, fast pointer will move another step. As you can see now, both the slow pointer and the fast pointer meet at this node where the cycle begins. Time complexity of the Floyd cycle detection algorithm is big O of n, and the space complexity is reduced to big O of 1 from the brute force approach. Now, let's look at the Java program for the Floyd cycle detection algorithm. Here, we will initialize two pointers, slow pointer and a fast pointer. Then, until the fast pointer is not null and its next of the fast pointer is also not null, we'll move slow pointer by one step at a time and we'll move fast pointer by two steps at a time. When slow pointer and fast pointer become equal, that means there exists a cycle in the linked list. Then we'll move the slow pointer to the head, we'll keep the fast pointer wherever it is, and until both the slow pointer and fast pointer do not become same again, we'll move both the slow pointer and fast pointer one step at a time. And in the end, will return the slow pointer or fast pointer, because both of them will be pointing to the same node, which will be the starting position of the cycle. Here, initially, when the slow pointer is moving one step at a time and fast pointer is moving two steps at a point, if the slow pointer does not get equal to fast pointer, that means at any node, the next element of fast pointer is null. That means there does not exist any cycle in the linked list. So in that case, we'll return null. If you like this video, then please hit the like button, share it with your friends, and subscribe to our channel.